Hi friends, greetings from Empower by Dr. NK. I am giving you a lot of tips on how to prepare for your CET as well as for PU board examinations. Of course, the CBSE students can also watch these videos because they are going to be useful for you. And if you want to have a one-to-one interaction with me and clarify your doubts or get guidance for specific chapters, download the Empower app now. I have given the link in the description box and also in the comments section. Don't forget to book a free one-on-one session with me anytime you are free. Today, I'm going to talk to you about the name reactions in organic chemistry. These are some of the important reactions which appear both in the main examination as well as competitive examinations. So, what is so special about the name reactions? You have a name for the reaction, and this name is usually the name of the scientist or the chemist who worked with this particular reaction. So it can appear in both preparation of compounds or properties of organic compounds. And what you need to focus here is the name of the reaction, the class of reactions to which it belongs, the reagents used, the different conditions in which these reactions take place, and the kind of reactants which are used in the beginning, and the class of products which are going to be produced. So these are the important aspects of name reactions which you have to remember, and they can ask you questions on any of these factors. Now today I am going to talk to you about Finkelstein's reaction. Here I told you the name of the reaction is important, and also the reactants with which we start off and the product which we obtain are very important. What we are trying to do here is we are starting with a primary alkyl halide, making it react with an alkali metal halide. And the class of reactions which take place here is a halogen exchange. You can see that in the primary alkyl halide there is a halogen. In the alkali metal halide also there is a halogen. These two halogens get exchanged and you get a different alkyl halide. And all these happen in dry acetone. Now let me tell you why this dry acetone is being used. Now we are talking about the different solubilities of the metal halides, and we're taking advantage of solubility of the one of the metal halides and insolubility of the other metal halide. And the whole reaction uses SN2 mechanism to happen. Now, if you take the initial metal halide, this halide is soluble in diacetone, whereas the metal halide which is formed at the end of the reaction is having poor solubility in acetone. So let us write the general formula. The general formula of alkyl bromide or alkyl chloride, since it is taking place through SN2 mechanism, I am writing the 3D structure for the alkyl bromide or alkyl chloride, and generally we use sodium iodide, and the bromide or halide, the bromine or chlorine in the alkyl halide is replaced by the iodine. So the resultant component will have iodine in place of bromine or chlorine. And since it is SN2 mechanism, you will get the compound like this. So if you want to take an example, Take ethyl bromide in dry acetone, and sodium iodide also is added to this mixture. Now, in presence of dry acetone, sodium iodide is soluble in acetone and it reacts with ethyl bromide. Halogen exchange takes place. Bromine is replaced by iodine, and the resultant compound will be ethyl iodide with the formation of sodium bromide, which has poor solubility in dry acetone. So, friends, they will ask you a question: how do you obtain a alkyl iodide from starting from another alkyl halide? It could be a bromide or a chloride. And they may ask you what is Finkelstein reaction, or they ask you why acetone is being used. All these are the questions which can be asked in this particular reaction. So, I want you to stay with me and book a session, free session with me to learn more of reactions or more of chemistry in an easy manner. I'm going to teach you how to remember all of this in an easy way. See you soon.